Hi, welcome back. So this is about precedence and associative. Let's solve few more problems here in this case. Associativity and precedence. Now in this case we can use the situation here. This is a GATE 2000 question, and it says that given the expression grammar, E derive E multiplied by F plus E, or F derive minus F, or ID. Okay. Now, question is again, which of the following is true? Okay. Okay. So these are the options are there in this case, that multiplication is having higher precedence. Multiplication is having higher precedence than plus. Option B is minus having higher precedence than multiplication. Plus and minus have the same precedence. Plus and minus have same precedence. And plus is having higher precedence than plus is having higher precedence than star. Okay. Now you know the lengthy method. You know that if I want to comment about star and plus, then I have to take a string of star and plus, and then I have to see that who is getting evaluated. The problem is the star and plus is in the same level. Okay, and I will show this situation to you, and later you try to you can use this thing, that see, if I have a star and plus in my single operator, like ID plus ID star ID, like this. Another string also I can take. Now what I can do here in this case, E derive E plus F plus E, F plus E I can write, and in the same time I can also have E derive E star F. Now it is my choice that what I am introducing. Okay, and both are giving me the flexibility. In this case, if I have done this, then I will expand this E, and I will introduce, now I can introduce plus over here. Okay, so it will become F plus E. I have already done with plus. Then I can go with star, and I can introduce a star over here by E star F. Okay, so I can get in both way. So first thing is that if they are in the same level, then their precedence is also same, because you can introduce any one of them first, any one of them later. So plus star and plus is having same precedence. Okay, they are having same precedence. And if you go by that rule, that level rule, if you go, that the first level is your star and plus, and the later level you are having minus, so definitely minus will be introduced later. Okay, so minus will be introduced, so definitely minus will have a higher precedence. Okay, so minus will have a higher precedence than plus, and then multiplication also. So in this case answer is B. Okay, and rest of the situation I want you to work on the rest of the option A, B, C, D. We have done with B. Rest of the option A, C, D you work on, and just get it that these are false. Okay, these are false result, that multiplication is higher precedence than plus. So I have already shown one parse tree where I can introduce multiplication first and then I can go for plus. So if I do this E star F, okay, and then I go for plus, that is F plus E, okay, then you will get a higher precedence over there. Okay, so this statement is false because of this parse tree. Work on this two part. Okay, try to get a different parse tree so that the string will become, the option will become false. Look at this problem, 2011. It's a very good question. GATE 2011. The question summarizes in this way: consider two binary operator. Up arrow and down arrow. Okay, and up arrow is having higher precedence than down arrow. Okay, up arrow is having higher precedence than down arrow. Okay, up arrow is right associative. Up arrow, okay, I hope you'll understand. Up arrow higher precedence than down arrow. Okay, up arrow is right associative and down arrow is left associative. Which of the following represent the parse tree for the expression? Which of the following represent represents syntax tree for expression 7 down arrow 3 up arrow 4 up arrow 3 down arrow 2. Okay, this is the expression, and we have options. We have options. Let me draw all the options are there in this. That we have a down arrow 7, up arrow 3, up arrow 4, and then down arrow 3, 2. Okay, we have option B, down arrow 2, down arrow 7, up arrow 3, up arrow 4, 3. Okay, we have a very limited space. Okay, anyway, let me draw it here only. C, down arrow 7, then down arrow 2, then we have a up arrow 3, we have a up arrow 3 and 4. We have option D, where we have a down arrow 2, then up arrow 3, then we have a down arrow, up arrow 4, then we have a down arrow 7, 3. Okay, so this is the complete question. Writing everything is sometimes very difficult, but anyway, so now we have to comment about using this thing that up arrow is a higher precedence than down arrow, and up arrow is the right associative and down arrow is left associative. So which of the following is the correct syntax tree for it? Okay, so let's use this information and do the parenthesization. Okay, and this will give you your answer. Correct parenthesization will give you the answer. So 7 down arrow 3, 7 down arrow 3, up arrow 4, up arrow 3, down arrow 2. Okay, now up arrow is a higher precedence, that means you have to evaluate this part first. Okay, 3 up arrow 4, up arrow 3 will be evaluated first, higher precedence, and it is saying up arrow is right associative. Okay, that means when there is a confusion, like here 4 is associated with which operator, then 4 will be associated with the operator on the right hand side. Okay, 4 will be associated with the operator on the right hand side. Okay, so the first thing that will happen in this case is up arrow 4 and 3. This part will be done first. Why? Because up arrow is the right associative operator. Then what? Then again up arrow 3. Okay, so now this is the second parenthesization. Now again you assume that this part is already evaluated, and with the evaluated part on both the side you have a left and right, you have an operator down arrow, which will be evaluated first. Okay, so because down arrow is a left associative operator, the first thing will be evaluated down arrow 7. Okay, you have to evaluate down arrow 7, and finally you have to evaluate down arrow 2. Okay, so this is the way it will be evaluated, and if you look at the options, the option which matches here in this case is B. Okay, so what you can do here is you can get the correct parenthesization. Okay, we can get the correct parenthesization, and you can evaluate your answer. Correct parenthesization will give you answer of it. Okay, so this is the answer. Same question based on your associativity and precedence rule. Okay, now this is one question that is very recently 2016 they have asked it, and this question says that there is an operator plus. It's a very simple question: plus, minus, and multiplication. Precedence is high, medium, and low. Associativity is left, left, right and left, or left, right and left, and binary. Okay, and the expression is given to you. That what will be this expression? 2 minus 5 plus 1 minus 7 multiplied by 3 will be evaluated to. Okay. Okay, now you have to be very careful with this thing, because things are very dynamic in the nature. It means things are not usual what usually we do as an expression, because if you change this thing, your expression value will also change. Okay, so what we have to do in this case is we have to go that plus is the highest precedence operator. Okay, if plus is the highest precedence operator, then 5 left and right side there is a minus and plus. You have to do the parenthesization, and it will be done in this way: 5 plus 1. Okay, so this will be evaluated first. Okay, according to the natural rule that it's the same precedence, but it is saying in this case higher precedence. So 2 minus 6 minus 7 multiplied by 3. Okay, see the things, how the things are being changing in this case. Okay, so first is plus, highest precedent, left associative. We didn't use that left associative operator in this case. Minus, the next operator is minus and multiplication. The minus is the having higher precedence than multiplication. So in this case minus will be done first. Within minus you have what? You have a associativity which is right. So now 6 left and right side, both side there is an operator minus, but 6 will be associated with operator on the right hand side. Why? Because the associativity is given here in this case is right. So 6 minus 7. So 2 minus, this answer will be elevated to minus 1 multiplied by 3. This is how it will look like. Okay, 6 minus 7, and that will become this. Now 2 minus minus 1 will be 3. 3 multiplied by 3, answer is equal to 9. Okay, so means it's very simple, you know, the question is very simple, but they have asked this question just to evaluate your, that if you change the basic rule, okay, then how this expression will be evaluated. Okay, so this particular expression is getting evaluated to 9. Let's see one more question. This is very latest, this year only, about this associativity, and this topic is important. Okay, among this, because they are, when the questions are regularly asked throughout the year, okay, within a gap of 1 or 2, the topic becomes important. So this associativity and precedence thing is one of the important topics in this, and there is a high chance that you will get a question from this particular topic. Okay, consider the following parse tree for the expression. Okay. A hash B $C $D hash E hash F involving two binary operator, involving 2018, involving two binary operator, hash and dollar. Okay, so hash A, another hash, then hash F, then we have a E, we have a dollar, we have a D, we have another dollar, we have B, and we have C. Now this. So now this is the parse tree, and this is the sentence that considers the parse tree for this expression, and this is the parse tree, and the question: which of the following is correct for the given parse tree? Okay, which of the following correct okay, so let's see what is correct about it. Options are given to you in this case. So these are the options which is given to you, that option A is dollar is higher precedence and is left associative, and hash is right associative. Option B, hash is higher precedence and is left associative, and dollar is right associative. Option C, dollar has a higher precedence left associative, dollar is right associative. Option D, hash has higher precedence and is right associative, dollar is left associative. This is the question, and the question is that is it sufficient? Do we have the sufficient information to conclude some results? Okay, if I have a random parse tree, I don't have a grammar, but I have a parse tree. So is it sufficient to conclude something? Okay, so now for that we need we need to understand the parse tree, and based on the parse tree, the parenthesis A hash B dollar C dollar D hash E hash F. Now to conclude this result, we have to understand if the expression is given to you. Okay, the first thing is B dollar SE, this is the subtree, B dollar C is the subtree. Okay, now this is the first parenthesization. Now this parenthesization is saying something. Okay, this parenthesization is saying something, that for B left hand side and right hand side, both side there is an operator. Okay, both side there is an operator. Okay, and both side there is an operator, and B is associated with dollar. Okay, B left hand side there is a hash and right hand side there is a dollar. It can be associated with dollar also, hash also, but it is associating with dollar. That clearly suggests this thing, that dollar is having higher precedence than hash. Okay, dollar is having, at least it's a local conclusion, because the amount of the information that you are giving is very local. So based on that I have to conclude something, and my options are something like this only. They are not saying same precedence, maybe may have, okay, but the amount of the information that you are giving me, I can definitely say that dollar is having higher precedence than hash. True, correct. Now you see another interesting part is that see, both the side there is a dollar, but again C is associating with the dollar on the left hand side. Okay, this is the second conclusion. If you say B hash B dollar C, C could have associated with dollar D also. That could have been done. But no, what it is doing here, that C is associated with this. So dollar is having higher precedence is one thing, and another thing is that dollar is left and right both side dollar. Who is getting first evaluated? Who is getting first evaluated? Left side. So dollar is left associative. Okay, all local information, but what we are doing here in this case, what we are doing in this, that whatever amount of the information that is given, we are concluding it. Okay, now so B has dollar, then you see that next subtree is this dollar D. That means this is again saying the same thing, that after dollar D, D could have been associated with hash, but again D is getting associated with operator on the left hand side, and that is dollar. Okay, so again it is saying, our evidence is enough for saying this thing, that dollar is having a higher precedence than hash. Done with this evaluation. Okay, the next evaluation will be done here in this case is E and F. This this is the subtree, this is also subtree, there is a hash, but this subtree will be evaluated first. Now what we can conclude, E left hand side and right side, both side there is a hash operator, but now E chooses what? E chooses to be on the to evaluate itself in this way, right? E chooses to evaluate it in this way, that is operator on the right hand side. Okay, and that means we can conclude that hash is right associative, hash is right associative. Okay, and then we can, if it is that, then this left and right both side there is an operator, so first this expression will be evaluated with hash, and finally A will be evaluated. So dollar is having higher precedence, left associative, dollar is having higher precedence, left associative, and hash is right associative. Okay, higher precedence, left associative. Did I mess up with some options? Dollar is having higher precedence. Acha, yeah, here it is hash, and okay, I think, okay, so which option is matching? Dollar is having higher precedence. Okay, dollar is having higher precedence and left associative, and hash is right associative. Dollar is having higher precedence and left associative. Option A is dollar is having higher precedence and left associative, and hash is right associative. Why the option dollar is having? Okay, this option is left associative, sorry, left associative. If it is the correct one, okay, if it is the correct, it is written incorrectly. So if it is the case, then dollar is having higher precedence and left associative, and hash is right associative. In this case your answer is A. Okay, so very much localized, yeah, true, but still your parse tree is giving you much more information to conclude. We have to only see how the things are getting parenthesized, and based on this parenthesization we can conclude the result. Okay, so I hope I am clear over here. Okay, so we are done with this part, that is called precedence and associativity rule. Okay. Okay, now parsing categories are there. Parsing is of two types. Okay, so we have two variations are there, that is called, one is called top down parsing and another one is called bottom up parsing. Okay, now so if I give you a, let's say here the example is very simple, as derive, let's say double A derives small a capital A, and A derive B. Okay, and now if I give you the string A B. So there are two things are possible. Okay, that I start with this S and try to derive W. Okay, that S derive double A. Okay, S derive double A, and A derive small a capital A, and A to B. S derive small a capital A, and A to B. So I try to do this thing. So I started with top, means S start symbol. Okay, and work towards leaves. Okay, work towards the leaves, that is top to down. Okay, that is one thing is possible. Another thing is possible is that start with leaves. Okay, so from the terms are important in this case. From S we try to derive W. Okay, S try to derive W from start symbol. From S, from start symbol or start symbol, we try to derive W. Okay, this is one thing. Another thing is that we start with leaves. Okay, we start with A B, we start with W, leaves. Okay, and W reduces to S. Okay, bottom to top. Start with leaves. Okay, so starts with W. Okay, leaves. Okay, and reduce it to. Okay, now this is the reduction, reduce to S. So there is a one way of going top to bottom, that is derivation. We'll try to derive. Okay, derivation, and here in this case the term is reduction. So derivation and reduction. Okay, so S to W or W to S, top down or bottom up. Now your understanding of top down and bottom up, it's a complicated algorithms. Okay, these are not very simple algorithms. These are quite complicated algorithms are there. And if you want to get the correct understanding of this algorithm, what you have to be very much comfortable with is the calculation of first and follow set. Okay, calculation of first and follow set is the basis of both the parsing, top down as well as bottom up. Okay, so both the parser uses top down and bottom up. Both the parser uses first and follow calculation. Okay, and that first and follow calculation will describe the algorithm, the behavior of the algorithm, how the top to bottom, and S derives W or W reduces to S. Okay, so we will first understand the entire thing in terms of top to bottom, bottom to top. Okay, and in that context we'll learn here. Okay, so first thing is first, that is top first and follow calculation. First set and follow set. Okay, now first set and follow set can be calculated for a non-terminal, okay, first and follow calculation. Okay, so first and follow calculation, and among them the first thing is your first calculation. The first thing is first set. Okay, the first set can be calculated. First set can be calculated for a non-terminal or first set can be calculated for non-terminal union terminal star also. For string of terminals and non-terminals also the first set can be calculated. Okay, so now don't have any concept in your mind that it is only for the non-terminal. It is not true. It can be calculated for terminal, for a string also. Terminal union non-terminal, it can be also calculated. Okay, the first set can be calculated for non-terminal, or first set can be calculated for non-terminal union terminal star string. Okay, within bracket let's say a string. Okay, so what is the rule? Rule is very simple. Rule is that okay, so for first set calculation there are small rules are there. Okay, small rules. So the first rule is first set calculation. Okay, if A derive, the best case, A trivial case, A derive A or A derive epsilon or A derive A followed by let's say B, C, D. Okay, anything. Okay, so this is the first rule. You have to be, that the best, the simplest rule. Okay, starts with a term, derive a terminal, derive null string, derive a terminal followed by non-terminal union terminal star, anything, anything you write over there. Okay, so either you derive a terminal or a non-terminal, terminal or epsilon or terminal followed by anything. Okay, first of A is equal to small a, first of A is equal to epsilon, first of A is equal to small a. Okay, you understand this very simple situation you are having is A epsilon or A B C D. Okay, so in this case include that symbol A, epsilon and A. Okay, so all the three situations are very much common situation, and in this case this is the simple, no calculation required basically, no calculation required. First of A is equal to the terminal epsilon or the terminal that it starts with. Write A, write epsilon, write A. First rule. Now, indirection rule, you have to understand only the term, you remember that. Okay, now second rule is that if A, second rule, if A derive B, C, D, okay, and B derives small b, C derives small c, and D derive D, that means D derives small d. Okay, that means A derive a string, non-terminal union terminal star, anything, string in non-terminal union terminal star, and starts with a non-terminal. Okay, starts with a non-terminal. Okay, so what you will do? First of A, again I have to do, so if it starts with a non-terminal, concentrate on this part. Okay, if it starts with a non-terminal, then first of A is equal to first of B. Okay, first of A, if it starts with a non-terminal, first of A is equal to first of that non-terminal, that is B. Okay, and in this case I will write the answer as capital B. Okay, second rule. So first rule, terminal epsilon, terminal followed by any string. Second rule, if it is a non-terminal, then first of A will be equal to the first of that non-terminal, and if it derive B, small b, then directly B. Okay, so this is the second rule. Last rule is about the indirection. Okay, last rule is about indirection. Okay, so third rule. S derive A, B, C. A derive A or epsilon. Two example I am writing here. B derive B or epsilon, and C derive small c. Okay, this is one rule, part A, and this is part same example. A, B, C. A derive small a or epsilon, B derive small b or epsilon, and C derive small c or epsilon. Okay, now I already told you this trivial rule, so you can directly write first of C is equal to small c, first of B is equal to B and epsilon both, because both the productions are there. First of A is equal to A and epsilon both. Okay, now problem is, what is first of S? Okay, so this is first of S. Now, what was the previous rule saying? That first of A is equal to, you have to be careful because this is the only complicated, not slightly tricky, otherwise the rest of the rules are very simple. The first of S is first of A. Okay, the first of S is equal to first of A. Now first of A, you go to first of A, there is a symbol, include that symbol, but there is epsilon also. That means A can be reduced to epsilon. But if A will be reduced to epsilon, your first symbol will become B. That means first of S, if it is replaced by epsilon, then first of S, again the second situation becomes first of B. Why it becomes B? Because A replaced by epsilon. Now go to B, first of B. So symbol B. But you can also replace it by epsilon. If you replace it by epsilon, then it will become C. First of C, C is C. So A, B and C. Okay. Now that means if something non-terminal is replaced by epsilon, okay, then you have to go to the next symbol. If it is a terminal, write that terminal. If it is a non-terminal, then your first rule will be calculated. Okay, I am repeating this calculation. This is the third rule, that A, first of A include the symbol. A replaced by epsilon. Then first of B is B, right here. If it is replaced by epsilon, then epsilon. Then next symbol C. First of C is C. Same calculations is there. The only thing is that this contains C and epsilon, this contains B and epsilon, and this contains A and epsilon. Okay, and now I'll say first of S. Okay, so rule wise, first of S. So rule says what? First of S versus first of A. Include the symbol A. If it is epsilon, go to the next symbol B. First of B is B. B. Include the symbol. If it is epsilon, go to the next symbol. First of C is C. And C is also deriving epsilon. Now you understand, A derive epsilon, B derive epsilon, and then C also derive epsilon. If all the three are deriving epsilon, then only include I epsilon production. So epsilon will be part of the first set in two cases. Either you have a direct epsilon derivation over there. Okay, either it is directly deriving epsilon over there, or it is deriving series of non-terminal. Okay, series of non-terminal, and all of them reduces to null, Okay, if it is the case, then only we can derive epsilon, otherwise not. Okay, so here we are not deriving epsilon because epsilon, but no epsilon. Okay, so no epsilon in this case. Okay, one more thing you understand. If the grammar is given to you, okay, this is a natural way of writing, because we naturally write the grammar in this way: start symbol first, then first to second level. Okay, it's better, it's advisable to calculate first set in bottom up fashion. Okay, calculate first set in bottom up fashion. Okay, so you calculate the first set in a bottom up fashion, because see, because there will be dependency. Bottom up fashion means you grow in this way, that you first calculate C, then B, then A, then finally S, because there will be dependency. So by the time if you say A to B, B to C, then C to A, then that will become a bit messy. But if you go in this way, that first C, then B, then A, you will be resolving the dependency one by one after another, and then finally you can reach to this calculation of the last one, the first one at the last. Okay, let's practice few examples. E derive T dash derive plus T dash or epsilon, T derive Ft dash, T dash derive star Ft dash or epsilon, F derive opening bracket E closing bracket or ID. It's a very standard problem. Okay, so very standard problem. Let's discuss this question. Okay, now in this case, again, what I advise you, that you start from calculating in a bottom up fashion. Okay, so it will be must first of F. Okay, now which case is applicable in this? Okay, so E dash, T dash and F is the terminal, non-terminal, and rest of them your opening bracket, closing bracket, plus multiplication, okay, plus multiplication ID, all are terminals. Okay, opening bracket, closing bracket, multiplication plus multiplication, all are terminals. Okay, so first of F, if you say first of F, so directly the case that is applicable, it starts with a terminal, starts two possibilities are there, and both are containing terminal and terminal. So I'll write here opening bracket and ID. Okay, opening bracket and ID, first of F. Okay, and it's better to always calculate in a bottom up fashion. I mean, it's not mandatory, but it is advisable. Okay, now next is first of T dash. If you say first of T dash, now first of T dash is equal to your star and epsilon. Okay, it starts with star and this is epsilon. Okay, so star and epsilon, star and epsilon. First of T. Now first of T, and that first symbol in this case is a non-terminal. If it is a non-terminal, then it starts with a non-terminal, then we know that first of T is equal to first of F, whatever F it is deriving. So first of T is first of F. That's why I say that first of T is equal to first of F, and now we have already done the calculation of F. Okay, first of T is first of F, and we have already done the calculation of F. So first of T is first of F, and it is now opening bracket and ID. Cool. First of E dash. First of E dash, direct case is there. In this case you have a plus and epsilon. Okay, so plus and epsilon, both are terminal. Plus is the one case and epsilon is the one case, so plus and epsilon. First of E finally. Okay, first of E, last one, which is the first symbol. Okay, first of E is first of T, and first of T is your first of first of t is already done calculation, opening bracket and id. So I think this is the simplest case you can have by which you can get this first set of each non symbol over here, okay, and these are the first set that is over here, okay. Now okay, okay, take a break, take a small break.